Hi guys, thank you for coming to our debugging workshop today. And we're currently recording this workshop. And if you don't want to show your face, you can just mute your camera. Yeah, so this workshop is going to be intro to debugging. Is going to be led by me, Mitch, and Emily.
So debugging is a very common experience that developers have to deal with, and developers tend to express very negative attitudes towards it because, as I'm sure many of you guys have seen, the process can be very painful. So hopefully, through the course of this workshop, we can help you guys have a more pleasant experience debugging programs. So what is debugging? The basic idea of debugging is it's the process of identifying and correcting errors or bugs in code. And it can range from something unexpected happening in a program crashing or not working at all, having something work in a way that wasn't the original intention, or having a disagreement about how the program is supposed to work, anything like that. But in particular, we're talking about situations where you expect the program to do one thing, it does something else, and you're not sure why. So the professors that teach Fundies 1, Fundies 2, and OOD provide a lot of resources and have this very dreamy, ideal picture of what the process of debugging is like for students, but things don't always turn out that way. So you want to go to the next slide? So professors tend to teach students about a lot of different tools. There's a design recipe that helps you create clean code. There's check expects and unit tests and all sorts of things like that that help you make sure that your code works the way that you expect it to. And then there are additional tools that help you find bugs, like the Dr. Racket Stepper and the debugger in your IDE, like in Eclipse or IntelliJ. But typically, students tend to use one of the following techniques. One, stare at code until the source of the bug has been identified, or make random changes and hope that that fixes the problem. And so this is sort of where the source of a lot of issues and misery when debugging come from. So this is the typical method that one might see when people aren't using one of these tools or some of the strategies that some of the professors of these courses or like a more formal method for debugging a program might use. Until the bug has been found, make a random guess about what the bug in a program might be, and to make a random fix to the program, changing some random code, changing what value there is in a variable or something like that, and then run the program again and hope that the bug has been fixed. And if it hasn't been fixed, do it again, continuing this process of making random changes and hoping it works. This is sort of just thrashing around in the code base, hoping that the random changes that you make work. So there is an advantage to this method, which is that if you were right on your first or second guess, then debugging is quick and easy. You finish in like a couple of minutes, your life is great, and you can just move on and keep working on the stuff that's more interesting, like working on features and adding new cool stuff to your program and things like that. But if you're not right within your first or second guess, there tend to be a lot of problems that accumulate. One is with all of the random changes that you make to your code base, you start to make your code unrecognizable. You add lots of weird variables, you move code around, create and add and remove random stuff, hoping that things are going to work. And by the time you have another chance to look at your code, you have no idea what anything does anymore. And you're lost with the changes that you've made. The second is that your guesses don't build up. Each guess you make is like throwing a dart on a dartboard, just hoping that you happen to hit the bullseye. You're not getting any better at hitting the bullseye. You're just making random guesses in sort of like a random spray of possible bug sources, and hoping that you guess right. And through all this process, you don't eliminate possibilities that you've already considered. You lose track of the things that you've already observed and already realized, and might check things again that you've already checked. wasting time degrading the code base and continuing to make your debugging experience significantly less than ideal.
So right now we're going to go through a practice for debugging. So so we have prepared a program earlier, and this is basically the code of the program, a very simple HTML with one functions in there. So what this program does is that it first initializes the count to be 4, and within this function full, we have a table initialized with an array of one element inside, which is count, the one that we initialized earlier, and we have a while loop while count is while like decrementing the count when the count is bigger than 0, we push an empty array into the table. And for this for loop here, we fill in with the numbers starting from 1 and all the way up to the table length, which will be 4, given that the count is going to be 4. So, and then return the table at the end. And at the end, we have a console log statement where we print out the actual value for the function full. So we expected that this function should produce an array of 4 elements in it, and it will be an array of the number 1, an array of number 2, an array of number 3, and an array of number 4. So that's our expected values. However, when we run the program, we see that the console log that the result that the console log gave us is an array of undefined. Does anybody have any idea why this happens? Yeah, so yeah, any ideas or?
On line 8, is that declaration putting a number in an array?
Yes, it should be putting a number in an array that counts. Like that's our intended behavior, I guess.
Oh, okay.
Yeah.
Is it bad practice to name count, to have 2 variables named count in different scopes?
That's a good point. So yeah, so I think those are some great ideas, and there are like a lot of good points for that. And we do want to get into the actual debugging practice very soon. So before that, we're going to talk about some debugging methods that we can use when we go through the debugging process. So the first thing that we're going to do is the approach that we're going to take for the debugging process is to first reproduce the bug. So what it means is to basically knowing what the bug is, that's your first step, and then try to run some different steps to reproduce a bug. And this step helps you to identify, kind of have a rough idea of why the bug is there and how the bug is produced from your program. The second thing is note the symptoms / observations of the bug. So as the program we looked at earlier, there could be multiple places that could cause the bug, such as the scope that was mentioned earlier, as well as the for loop or while loop. They can also be the potential places that will cause the bug. So just have some guesses and hypotheses in this step to kind of identify what the potential causes will be for the bug in your program. The third step is to identify the root cause of the bug. So this part is very important because this is when you will know how the bug is produced and how you can go from debugging your program with the root cause that you just found. Some strategies identifying the root cause will be kind of look at your program top down, or just look at your program within the function or any lines above or below where the bug is produced. The fourth thing is implement a fix to the code base. So this one will be the actual fixing part, and we'll also talk about some strategies of how to go with the fixing part later on. So yeah, as we mentioned earlier, the third step, identifying the root cause, this is the hardest part because this is when you will know how the bug is produced, and this is when you actually design how you are going to um, debug your bug. Oh, I guess just debug. Yeah, so some ways to identify where the root causes is first to generate a new hypothesis. So generating a new hypothesis means that you first have a guess of why this bug exists in your program. Um, and the second thing is to use your hypothesis and test it with different methods, whether writing a new functions to it or write out some print statements or anything just to test out if your hypothesis is correct. And the third thing is note how to narrows where the bug, what the bug could be. So we don't want to have hypotheses here and there, and then have hypotheses in this file, um, and then change to another file to have another new guess. So this one, this way it will be kind of messy just to like narrow down where your bug is. The better practice will be to have um, to have a general hypothesis of where the bug lies, and then narrow down the scope of um, where the bug will exist. So going from functions to functions, or going from top down design, or even just going through line by line, um, because sometimes like a semicolon could be like the bug, could be where the bug is. So this is what this step is going to be, basically narrowing down your hypothesis to the point when you eventually find what the root cause of the bug is. The fourth thing is go back to the top. So this one is when you have a hypothesis, when you narrow down and you see that, oh, this is not really why the bug exists, then in that case, you want to go back to what your hypothesis is and sort of sort out your thoughts and maybe have a new guess of where your bug will be, and then repeat the process.
So in terms of the ways that you can actually go about starting to debug, we're going to talk about three. So logging, using the debugger, and then using Google. So for the first one, for logging, some examples of this are console logs, print statements, system.out.println, and logging is used to help you understand where the problem lies in the program. It's not usually that helpful for figuring out like why something is happening, but to get you started on where you should be looking in the code, this is a great way to go. So then next is the debugger. So some examples are Dr. Racket's Stepper, Chrome debugger, and your IDE's debugger. So you can use a debugger to inspect the values of an expression at a part of the program. This is really nice when you know where you're looking in the code base and you kind of like have maybe an intuition of like what's going wrong and which function. So you can just set a breakpoint in your code and run your program and kind of step through and see what the values actually are. Because most of the time, like it's an issue with things are not working as you assumed they were. And the debugger is really nice because it lets you actually see what things are versus like what you assume they are. And then finally, Google. So you should definitely do a Google search when you run into a common problem, or if you've like figured out your problem, but you're still unsure as to like why it's working now. So Stack Overflow, blogs, and other software forums are great resources, and you'll probably find a lot of your answers there. But just a note, like not to plagiarize code, but it's like a good resource to learn more about what you're doing.
Yeah, so now that we went over some of the practice of how you debug, we'll actually dive back to the code we looked at earlier and actually debug the program. So yeah, if we look back at this code, the first thing that we can do is use the debugger on the on Chrome or on Firefox or Safari, which is this tab. By accessing this part, you can always go to the developer tool to open the developer tool and then go to this tab for debugger. And here you will see the source file, basically like what your program is going to be. And first thing first, since we know that this program does not print out what we want it to be, but instead printing out an array of undefined, we'll probably first, so we can have the first assumption of being, oh, maybe the while loop doesn't doesn't like add um, the while loop doesn't add like empty arrays to the table. So we can first put a um, breakpoint at line 10. So after you put a breakpoint at line 10, you want to refresh the page. And now um, in here, you can see what the program gives you with the breakpoint setting at line 10. So as we can see that right now the table has um, a value of undefined, and we can see that the count is also undefined. So this should give us a rough idea what's going on here. Basically is that the count in this case in line 10 is not a defined value. So next, because of this assumption, we know that, oh, maybe the count is not defined, which could happen a little bit before line 10. So then we can put a breakpoint at line 8 instead, just to check if count is defined at that place or if the table is defined at that place. So similarly, we'll set the breakpoint at 8 and refresh the page. So at line 8, we see that, oh, the count is also undefined, but the table is also undefined, meaning that at this point the count is undefined, which causes the later count in this while loop to be undefined, and also of course the for loop and eventually the table, the value inside the table. So once we find out that the count is undefined, this is the first part we can this is the first strategy that we can kind of use to identify sort of like a rough idea of where the problem could be. And the second thing we can do is to use some print statements, which is the login strategy that we talked about earlier, to put the login in your code. We first need to figure out where exactly we should put the logins or the print statements, because having those print statements at like the correct places would be helpful. Like at the correct places would be helpful in debugging, since you don't want to just like put those print statements like randomly, because they won't help you. So since we know that a count at this point is undefined, we can probably print out we can console log the count before line 8. Before line 8, meaning that we want to check if the count is defined at that place. However, since we know that we initialize the count before the function, we also want to print a count after the initialization, just to see if the count is actually being initialized after line 6 in the program. So additionally, you can also put a count after the while loop, just to double check that if the count is actually being either initialized or like what sort of value that it has at line 15. So these three places will be the parts where we can check whether or not count is defined. So if we go back to our program and look at the console, we can see that in the console, we can see that in line 7, which is the first count, first print statement count, has a value of 4, meaning that this count initialization actually initialized the count up to be 4. However, if we go to line 9, at this place, which is inside the scope of the function, we can see that it's becoming undefined. And then similarly on line 15, the count is also not a number in this case. So the part where it actually changes is from line 7 to line 9. And the crucial difference in this place is that it's the count, the print statement of count in line 7 is outside the function, while the print statement of the count in line 9 is inside the function. So now we narrow down to where the bug is, and we now want to know why this is the bug. So in that case, we'll go to our third strategy, which is Google. With Google, we can kind of, because like this is sort of a common practice of JavaScript, we can use Google to kind of giving us an idea of why this happens, of initializing a variable outside of the function or inside of the function, and why this is different. So with some sort of question, with that kind of question in mind, we can search up JavaScript, why is variable not in the scope of the function, and we find that the first Stack Overflow page sort of it's just an example of like the Google search kind of tell us the answer why the variable count is not defined inside the scope. So as you can see here, it says that outside some special cases of global and module scope, variables are declared using var, which is function scope, let block scope, and const as block scope as well. So this can be like a general idea of why the count is not initialized inside the when you try to access it inside the function. So I guess one way to fix this problem is that after we identify the cause of this problem, we will probably think that the first immediate solution to that will be moving moving the count inside the function. And as we can see, sorry. Yeah, as we can see that right now, after moving it inside, we see that it's producing what we're expecting, which has like 5 values with 4 inside first, and then the array, and then 4 arrays afterwards. So yeah, so this is just a very simple idea of how you would debug a program.
Okay, so next we're going to talk about like a short intro to the web console. Okay, cool. So the first tab, which is the inspector or elements tab on the Chrome debugger. So this is where you can see all of the HTML code, as well as all of the CSS styles that are coming through. So if you're ever having like issues with styles or something not showing up on the page, and it's an HTML element, it would be good to look here first to see what's going on. The next tab is the console tab. So this is where any console logs that you put in your code or console errors that happen will pop up here. And then the next one is the debugger or the sources tab on Chrome. So for the debugger, you can see your source map for all of your files. And you can basically just set breakpoints and like refresh the page. And if it's hit, the execution will be paused and it'll allow you to step through your code to see what's actually happening. So this is super useful for debugging on the front end, and you can like watch certain variables and kind of just like see what's happening. And then the next tab is the networks tab. So this is really helpful for when you're debugging HTTP requests. As you can see here, pretty much like whenever you refresh the page, this will be populated with the network calls that are happening. And you can see here like the status, what it is, like a get or post request or another one, and then kind of like the result, the headers, pretty much everything that you need to know is here. So this is also nice if you're fetching data and it's missing, to actually see like what's happening with the calls and what data is coming back. So that's kind of just like a very quick overview of the things that you can do with the web debugger.
So when dealing with bugs in a program, you'll probably get the idea that fewer bugs is generally better. The fewer errors you have in your program, the less debugging you need to do, the easier your time is working on the program that you're building, and the more features you can work on. So the question becomes, how do you make it easier for you while you're writing new features or new pieces of your program to reduce the number of bugs that you have to deal with or make it easier to find those bugs. And the primary tool that developers use in achieving this goal is testing. All of you have seen testing in some form or another in computer science classes at Northeastern. It includes check expect from Fundies 1, the testing library from Fundies 2, and JUnit in object-oriented design. These let you describe the behavior of your program using a test and then verify it by running those tests. And they'll succeed if the program does what you expect it to do and fail otherwise. So testing allows you to identify bugs before they become a problem. Essentially, if there's a bug in your program or you've written code that has a bug in it and you've written a test that explains what your program is supposed to do, and it's going to blow up and tell you, hey, this part of the code isn't doing what you expect it to do, or this function isn't doing what you expect it to do. This lets you solve two problems at the same time. First, it makes sure that new code that you've added works as expected. When you write a new function and you add some tests for it, if those tests fail for your function, then you know that the function has some issue with it and you can quickly fix it before you release that code to your program or submit it for an assignment. And the other important thing that testing helps you do is make sure that your code still works after you've changed something. So for example, if you create or change a function that you were using before in some other tests, and some of you're able to do what you wanted to do with your new code, but some of the tests you wrote from 3 weeks ago start to fail, you know that before submitting your assignment or releasing your program or something like that, there's something wrong with it. So you can go fix it based on the output from those tests. And therefore, those bugs don't end up getting as far as they would otherwise. So the moral of the story is, if you write good code, follow good design principles and have tests for your code, then you're going to have fewer bugs and it's going to be a lot easier to debug them. It's going to be a lot easier for you to understand how your program works, and you're going to have a better idea of where the bugs have occurred and what the source of the problem is. So at this point, we sort of covered all of the main ideas of what we wanted to talk about in regards to debugging. So we wanted to relay a little bit of our experience while debugging and talk a little bit about sort of the lessons that we've learned over the years, working on big programs, on code bases, and on co-op while debugging, debugging in those types of environments. So for me personally, my experience was that, especially in Fundies 1, Fundies 2, and OOD, I was sort of always following that thrashing method. I was just like constantly hoping that some change that I was going to make was going to fix the problem, and I keep digging myself a hole that was deeper and deeper because I'd make the code just complete, spaghetti. And by that point, I may have added new bugs. I have no idea what's going on at that point, and I need to potentially rewrite everything or start from scratch or something like that. And so it's a really unproductive process. Recently, in a lot of the code that I write now, I tend to rely very heavily on the logging process to sort of print out what a variable evaluates to at different parts of a program, so that I understand where that variable is changing or where it starts to have a value that's not right, and sort of use that to look into the values of different expressions in the program. At the same time, I also want to spend more time using a debugger because it's a very useful tool. And it would definitely make my life a lot easier than running a program like 10, 20 times to print out a different thing every single time that I go through this process. So, yeah.
Yeah, I think for me, similar experience where in Fundies 1, Fundies 2, and OD, I didn't really know how to use the debugger and was kind of just using the thrashing methods. But I think in co-op, I've been definitely relying on the debugger a lot more, especially for front-end code. And also just using the networks tab a lot. If you're relying on code from backend services, it's super helpful to just use that if you don't really know what's happening on that side of the code base. So I think that's been really valuable. And then also kind of learning how to debug CSS issues through the Elements tab has been super useful as well.
Yeah, for me, I think at the beginning, of course, I was also trying a lot of different ways to see where the bug is. And it's like pretty slow in that case. And on my co-op, I learned how to use like the logging system in Python, as well as the the debugger, or the networks tab, in particular, in the developer tool for backend code. So I found them really productive and pretty fast in debugging because generally you can see exactly what sort of response the server will give back to you, as well as like you by using like the login system, you can see what kind of like results you would get at each point of your code. So I think that definitely helps me in um, debugging and make the program more bug free. So yeah, thank you for coming for our workshop today. I hope you guys enjoy it, and